This is section 4.4, part 1, where we are going to factor trinomials. And the big difference between section 4.4 and 4.3 is that your leading coefficient is no longer 1. You can see you don't have x squared plus bx plus c. You have ax squared plus bx plus c, which indicates that you have a number not 1. And that's going to change the way you factor these trinomials. So you can no longer just find the factors of c that add up to b. We have to use that a as well. So you want to find the factors of the a times c, so the product of a and c that add up to b. The good news is that by looking at the pluses and minuses, that those rules are still the same. So here in this problem you can see you have two pluses. We've got a plus bx and a plus c. So we want to find the factors of positive c that add up to positive b, which are going to give us two positive factors. Those pluses and minuses, the combinations, will still be the same as in 4.3, and you'll see that. So let's just jump into it, and let's start our first problem. So we want to look at 2x squared plus 11x plus 12. So we want to find the factors of a times c, or 2 times 12, that add up to 11. So 2 times 12 is 24. So we want to find the factors of 24 that add up to 11. So you're going to go through and you're going to look at them, and you'll see both factors are in fact positive. So we'll start with the number 1. So we've got 1. 1 goes into 24 times. So 1 plus 24 is 25. That doesn't work. We're looking for 11. So let's try 2. 2 goes into 24 12 times. 2 plus 12 is 14. Still not 11. So let's try 3. 3 goes into 24 8 times. 3 plus 8 is 11. So that's the number we're looking for. See, these are the factors we're interested in. Alright, so unlike 4.3, we can't just wipe our hands and say, okay, x plus 3, x plus 8, we're done. Nope. Alright, it is different, alright, because of that leading coefficient being not 1. It's going to change the way we factor. Alright, so what we're going to do is we're still going to have two quantities, but instead of them being connected by multiplication, they're going to be connected by addition, always. You can always think of them as connected by addition. And then you're going to look at your two terms, your two outside terms in the given trinomial, and you need to drop those down. So the outside term, 2x squared, stays the outside term. The outside term of positive 12 stays the outside term there. So I've dropped down my two outside terms. Then I'm going to go ahead and come to my factors of 3 and 8, and I'm going to plug them into the two empty spots. It doesn't matter. I could put 3 here, 8 here. But what you have to do is you have to add the variable to each of the factors. So our variable in the problem is x. So I'm going to add 3x here and 8x here. 3 is one of my factors, add an x to it. 8's another factor, add an x to it. Next, we're going to go ahead and look at each of these quantities individually. Alright, I'm going to factor the GCF out of each of them, the greatest common factor. So what's the greatest common factor in this first binomial? It looks like it's simply x or 1x. So I take an x out of this term, and I'm left with 2x. Take an x out of this term, and I'm simply left with 3. So I've got x times the quantity 2x plus 3. Now I'm going to look at the second binomial. What's my GCF here? Well, I've got 8 and 12. Looks like 4 goes into the 8 and 12 evenly. So 8 divided by 4 is 2x. 12 divided by 4, that gives me 3. What do you notice? I see two quantities that are the same. Alright, so if you have two quantities that are the same, you know you're in good shape, because after you factor your GCF out, alright, these two quantities, alright, should be the same. If they're not, you've probably done something wrong. So that's a good indicator that you should go back and re-look at the problem and see what went wrong. Alright, but we're in good shape. Both our quantities are the same. So I'm going to factor the 2x plus 3 out. So essentially you can think of it this way, where whatever is written twice, you simply write once. I'm going to factor out the 2x plus 3. Then I'm going to look at the information that I have outside of the two quantities that are the same. So I've highlighted it here. Go ahead and read that. It reads x plus 4. So that's simply what I write here. So whatever quantities written twice, write once. Whatever information is outside that quantity, those quantities, write once as well. And your answer is 2x plus 3 times the quantity x plus 4. And again, you can use foiling. I'll do it once here in this video, all right, to check. All right, you can always do that. So I'm going to FOIL 2x times x, and I get 2x squared. 2x times 4 gives me 8x. 3 times x gives me 3x, and 3 times 4 gives me 12. Add my middle two terms together, and I get 2x squared plus 11x plus 24. And we see the two quantities, the two trinomials are exactly the same. So you should be confident that you factored correctly, and the quantity 2x plus 3 times the quantity x plus 4 is in fact correct. Alright, so let's go ahead and look at a second one of these. Alright, so we've got 5x squared plus 16x plus 3. So I want to find the factors of 5 times 3, or 15, that add up to 16. So start with 1. 1 goes into 15 15 times. 1 plus 15, hey look, that's 16. Got it on the first go this time. Alright, so we're going to use the factors 1 and 15. So remember, two quantities separated by addition. Drop down your outside terms. And then you take your factors and you plug them in the two empty spots. And really it doesn't matter. Before I put 1 first, or the first factor, you could put 1x or you could put 15x here. I'm going to put 15x here. And I'm going to put 1x here. Really doesn't matter. Alright, you could have switched it up. You should still get the same answer. Alright, so again, let's factor out the GCF. So between 5 and 15, looks like 5 is the greatest common factor. Between x squared and x, oops, open the parentheses too quickly. 5 and 15, 5 is the greatest common factor. Between x squared and x, x is the greatest common factor. So together, we're going to pull out a 5x. 5x squared divided by 5x is simply x. 15x divided by 5x is going to give us 3. Alright, there's no common factor between the x's, or the only common factor you have here is 1. So when your only common factor is 1, especially in the second quantity, please write that. Please write the number 1. And then 1x divided by 1 is simply 1x, or x. 3 divided by 1 is still 3. As we saw previously, we've left with two quantities. They should be the same, and ours are. Alright, and then we're also going to be interested in these outside terms as well. So the two quantities that are the same, x plus 3, I write once. And then I look at the information outside the parentheses, which is the 5x plus 1. And that gets written as well. And there's your answer. And again, you could check by foiling. So let's come down to the next type of problem, which is ax squared minus bx plus c. So we're still going to find the factors of a times c, and now they're going to add up to negative b. And now both our factors are going to be negative. So I've got 3x squared minus 14x plus 8. So I'm going to find the factors of 3 times 8. 3 times 8 gives us 24. So the factors of 24, that add up to negative 14. So start with 1. 1 goes into 24 24 times. We know both factors are negative. So negative 1 plus negative 24, negative 25. Negative 25 is not negative 14, so those factors of negative 1 and negative 24 aren't helpful to us. So let's now go on to 2. 2 goes into 24 12 times. Both factors are negative. Added together, we do get negative 14, which is the number we're looking for. So negative 2 and negative 12 are the factors we want. So we've got two sets of parentheses separated by addition. Drop down your outside terms. Take your factors, plug them in. Remember to add that variable. So I've got negative 2x and negative 12x. Look for your GCF. The only common factor between 3 and 2 is 1. And I can pull out an x. I'll pull out a 1x. 3x squared divided by 1x is 3x. Negative 2x divided by x is negative 2. Now I've got negative 12x and 8. I'm going to point out we do have a leading, what happened to that blue highlighter? We have a leading leading coefficient in that quantity that is negative. Whenever you do have a leading coefficient that's negative, please pull out a negative GCF. So whatever number you have, if this leading term here is negative, make sure you're pulling out that negative number. So what's the GCF between 8 and 12? Looks like 4. So I made it negative, so I'm pulling out a negative 4. So negative 12x divided by negative 4 is positive 3x. 8 divided by negative 4 is negative 2. If you can see that our two quantities are the same, as they should be, and we're going to look at this outside information as well. If you did not pull out a negative and you pulled out a positive, you would have a negative 3x plus 2. So it would be almost the same. You would just have opposite signs. And when that happens, you should go back and say, whoa, I must have not have pulled out a negative, so go ahead and go back and pull out that negative, and you then should have the same quantities. And we'll look at that more in class as well. So whatever's written twice, you write once. And then what's on the outside? Oh, we've got x minus 4, or x plus negative 4. It's the same thing. There's your answer. Let's try one more for this part, and then we'll be done. So we've got 4x squared minus 9x plus 2. So find the factors of 4 times 2, which is 8. That add up to negative 9. We know both factors are negative, so let's start with 1 and 8. 1 plus negative 8, well, that's negative 9. So we've got our factors on the first go, because negative 9 matched negative 9. So we've got two quantities separated by addition. I'm saying that over and over again, so you remember. So drop down your outside terms. Go ahead, plug in your factors. I can plug in negative 1x here, negative 8x here, or you could have done it vice versa. This way, GCF looks like it's just x. So I've got 4x minus 1. I've got, hey look, I'll highlight it in blue again, a negative leading coefficient. So I want to make sure I'm pulling out a negative GCF, which is going to be a negative 2. Negative 8x divided by negative 2 is positive 4x. 2 divided by negative 2 is negative 1. And by making sure we pulled out that negative, we now have two quantities that are exactly the same. So whatever is exactly the same, we write once. And then whatever information we have left on the outside of our two quantities, which in this case is x minus 2, we also write that once. And then you have your answer. And that's the end of part 1.